Welcome. In the current video, the process of performing fatigue analysis on seam welds based on the Volvo method will be followed. In this example, a static model with seam welds of various types is employed. The model consists of two subcases, although only one is used in the fatigue analysis. The phenomenon will be studied in the time domain. To begin with, a new task is created, in which the model is loaded. For this action there are two ways. The user can load either the geometry or the results file. Easy recognition of seam welds is succeeded through the Connection Manager. There is a seamless collaboration of ANSA Connection Manager with Fatigue Connection Manager. So, in case of geometry file, the connections can be identified directly if ANSA comments exist. Otherwise, if ANSA comments do not exist or in case of loading a results file, they can be defined manually through the Connection Manager. For this case, the geometry file is loaded. Open the Connection Manager from the Task Ribbon tab where the connections are listed as they are read from ANSA comments. The various seam weld types with their different sides, base offside, sheet side, their respective thicknesses, and the number of rows are detected and assigned accordingly. New connections can be added by Pick button. In the new window that opens, the desired seam weld type can be selected. The next step is to set up the material for the model. Access the material database, go to User Defined and create a new one. Move to the Seam Welds tab and define the desired values for both SN curves that are needed according to Volvo method. Select the material, and with the use of the arrow place it in the Session Materials list. Switch to Assign Materials and choose Assign Material to Seam Welds. Select the material to be applied to all the connections. Moving forward, go to the Analysis Configurator window so as to fill in the necessary analysis parameters. The current analysis is a stress-based fatigue analysis on seam welds, using the uniaxial method in the time domain. The input results are static. Volvo Firmer method is used. The rainflow algorithm will be applied and the calculation type is weld normal. As for FE results, the type is grid point forces, which are being transformed to the corresponding stresses. The solution location is weld center and for shell layer choose according to weld type. Finally, Miner's rule is employed to determine the accumulated damage. At the end, press Save. The next important step is to define the loads, so access the loads database. In the present session we will load a time history from the appropriate file. Press the Import button and load the desired file. The curve has 1000 points with a time increment of 1 second. Then, switch to Assign Loads to assign the loading to the static subcase 1. Select the box of Event 1, Channel 1 and click on the Time Series button. Load the results file. Combine the first subcase with the respective curve. Subsequently, the scenario has one event. Finally, optionally specify an output path in order to save the MetaDB with the results that will be output. Select all in entities to calculate so that all the connections will be considered for the fatigue analysis. Finally, run the analysis. Once the analysis is completed, results can be displayed through the dedicated plots of fatigue. Transparency can be applied to the rest of the model through the Connection button. In the Plot Properties area, through Fatigue Analysis Type, results such as damage, life in repeats, life in seconds, log of damage and log of life can be viewed. Analysis type results can illustrate the static condition, where the static internal forces and moments can be viewed. Moreover, enable the annotation on worst flag to identify the element with the maximum damage. Check the specific location where this damage value occurs as well as detailed information. Switch to Post tab, open the time series plot. Then, the input and stress signals will be displayed, by default for the worst element. Results can also be displayed by connection. By default, this option displays the worst connection and the worst element. All 2D plots have a direct interaction with the model. So, by modifying the parameters, the plots are updated. Choose the events plot for an overview of the damage and life of all events as bar charts, as well as a total life and damage bar. In the current scenario, there is only one event. Similarly, the events plot can be focused on certain elements or different location. For example, through the option Display by Connection, the user can select a specific connection's results. Another capability is the rainflow matrix. Each identified cycle has a mean and amplitude value. Z-axis can be the number of cycles or the cumulative damage of the cycles that belong to this bin.